In this video, we are trying to calculate the derivative of e to the power of x, and we'll be using a graphical approach towards it rather than an analytical approach. So what I have done is I have sketched the graph of e to the power of x. All right, and this is how the graph looks like. It's an infinite curve, extends to both the sides, and increases as x increases. Y increases as x increases. I have considered a point on the curve. Okay, this is my point. And now, since I'm interested in calculating the derivative for a particular curve, so we already know that to calculate the derivative graphically, what we need to do is we need to draw a tangent at that particular point, and the slope of the tangent is what gives us. So at x is equal to 1.15, my derivative is 3.16. I mean, that's the whole idea of using tangents to calculate the derivative at a particular point. Now going ahead into this, my function is e to the power of x. Now here is the interesting thing. Now once I move my point, right, let's say I'm interested in another point, let's say at this point x is equal to 2.11, my derivative at this point is 8.21, and the interesting thing is my y coordinate is also 8.21. Now let's try to move other points, and you will clearly observe that your y coordinate is almost same as of the derivative, and it is independent of points. I mean, I can keep on extending, see 2.2 to 2.63. So these values are almost same, and that too both the sides. See here is 0.17. If I go down here, 0.1, 0.07, 0.07, 0.06, 0.05. So what it tells us that the derivative of e to the power of x is nothing but e to the power of x itself. So that's a very interesting function which we have come across. So to verify, f dash of x of, I'm just calculating using GeoGebra, it's nothing but e to the power of x. So you can clearly see both the functions overlap each other. So we will be focusing on e to the power of x, and we'll have problems in our syllabus of chain rule, product rule, quotient rule, including, we'll have e power of sine theta, or, involvement of e in, different type of composition of functions. So that will be the whole point of it. And in case you want to look at the proof, there are various proofs for e to the power of x. You can give an algebraic treatment to it using the first principle. I think that is one of the best ways to approach whether how derivative of e to the power x is e to the power of x. You can definitely try to that, and in case you have any doubts and clarifications, you can ask me. Okay, then take care and have a good day.